Welcome back to Eclipse on Tap, the podcast where we talk about eclipses of all kinds and space in general. Crack it. Ooh, those were some nice ones. Episode 87 in the month of August here, late August. We were just chatting before the show how crazy it is that it's almost fall. But we're very excited to welcome back, third time now, a true Eclipse on Tap veteran, Dr. Gordon Telepun. Welcome back to Eclipse on Tap.
Hey, thank you guys for having me back. It's a pleasure and an honor to, share information with you, even though this is a little different than the eclipse stuff that we have talked about in the past.
That's right. Yeah, we're here to talk about something a little different. We've chatted about it a little on the podcast.
A little bit. Yeah.
We have the Titan Submersible, the tragic event that just has some extraordinary details that really are mind-boggling. So Gordon has found a lot of interest in diving into, no pun intended, the submersible story of Titan and all the things that went wrong. And he has authored a book called Titan, to the Titanic and Back, 13 and a half times, stories about bad decisions made. It's a incredible book that details a lot of what you may have seen in these documentaries recently on Discovery Channel and Netflix. Maybe they don't fully go into the detail that Gordon has. So appreciate you so much for being here, and ready to talk Titan.
Yeah, I'm happy to do it. Let me just give you a little background on why I'm even interested in this. I'm interested in all science and technology, and of course, solar eclipses and astronomy. But one of the things that also interests me, and always has, is engineering disasters. I mean, engineering projects that go wrong. So, bridges collapsing, buildings collapsing, dams breaching, things like that. I've always followed that stuff. And it kind of starts back actually because of my interest in space, wanting to know why the Apollo 1 fire started, or the Challenger accident and the Columbia accident. And the most recent one before Titan that I followed quite a lot, because they also did have some live hearings on that one, was the pedestrian bridge collapse at Florida International University. I don't know if you guys remember that. That was another fascinating one about poorly executed engineering and bad decisions when things were going wrong. But the thing about OceanGate and Titan versus all of these other interesting engineering problems that I've followed through time is I can't remember. I mean, I may be missing it, but I can't remember an engineering disaster that has a primary figure like Stockton Rush as the focus of the whole thing. So, I mean, it's such a complex story, and it has a lot of engineering. It has a lot of different personalities. And then you have this guy, Stockton Rush, which is, he's just an interesting guy. Unfortunately, he made some bad mistakes. And then, you put on top of that the fact that the Coast Guard did, 9 days of live hearings, and the news story that was all over the news for 4 days, when the Titan was lost and they thought they could save him on the bottom of the ocean. I mean, there's just never been a story like this. So I was really captivated by it. And what I did was I started off by doing YouTube videos. I did, I think, 13 YouTube videos breaking down different aspects of this story because it's so complex. You can't do it in one video. And I made all these custom graphics, and I took the Coast Guard graphics off of YouTube, and I customized a lot of those to make it more educational. And, I said to myself, I've gone through all of this work, and if you don't watch YouTube and you don't watch all these episodes, nobody's going to learn about this. And there was so much misinformation on the news about it and on social media about it. So I took all of that work that I had already done for my YouTube videos, and I decided to put it in a book form. I mean, it was just kind of a labor of love to get the information out there to the public so that people on the forums could argue about things if they wanted to, but at least with some baseline real information and not just rumors and hearsay. So that's how that all came about.
Dr. Telepun, I got to ask, were you following this prior to the disaster, or did the disaster kind of get your attention on the whole matter and start investigating it?
That's a great question. No, I didn't even know about OceanGate and Titan until the disaster.
Okay.
Yeah, that's a really good question.
Yeah, the backstory of OceanGate is certainly revealed much more than meets the eye from what we all heard when the tragedy was unfolding. When you do watch the documentaries, I thought they were overall pretty well done, but I could see, I feel like anyone that watches it can probably recognize they're interviewing a select group of people. They can't necessarily cover all the details in just a 2-hour documentary or whatever it is, an hour and a half, and several episodes, whatever it may be. So filling in the gaps here, it's we're highly interested, excited. And yeah, Gordon's book is available. I guess let's shout it out now. I'll put it up on the screen too, just while we're at the top of the show. Where can people buy the book if they're interested?
Yeah, so I have a landing page for the book, which has information about it, the recent reviews. The reviews have been great. And then all of the links to get the different versions. And the landing page is easy to remember. It's www.titandives.com. So www.titandives.com. And the book is available in, that's exactly right. The book is available in a lot of versions, a lot of formats. So I published, the paperback through Amazon, the Kindle version through Amazon. Then there's an ebook for iPads. There's an ebook for Android tablets. And then there's a PDF download. So there's a lot of ways to get it, and enjoy it. There's nothing like, and you guys have a copy of it, there's nothing like having the physical book in your hands to flip through and, just flip through and look at the pictures and go from chapter to chapter and figure out what you want to read or compare. So it was a lot of work, but it was worth it. I mean, I really enjoyed it, and I enjoyed talking to people about it.
Yeah, and it's certainly impressive. All of the effort you put into Eclipse content, whether it be your YouTube channel, the books that you've written in that regard, just the resources you have. Like I'm just so impressed by the wealth of knowledge you have for yet another topic, right?
Yeah, I was going to say I'm excited to learn more about it because, like we've already mentioned it, initially when everything came out, you're just listening to basically the news and the bits and pieces that they're feeding you, which isn't the full picture, and you can get so sucked into whatever narrative they're trying to push. For the first few days, it was just how much oxygen is left and how much time do they have left, that kind of thing. And
they knew that they were gone at that point, didn't they?
I don't know.
They didn't admit it, but they basically knew.
Yeah,
I'm not really sure.
That's a great point that you bring up. During the time that they were lost, they were interviewing James Cameron. And, Cameron has a lot of contacts in the deep submergence community. And he was interviewed, and he said that people in the deep submergence community had some contacts, I guess, in the military or something. So they knew that the sound seeking sonars we have out there, I guess for military situations, picked up the bang.
Wow.
And so he knew it. I mean, he knew they were gone. And, then that recent video of Wendy Rush hearing the thump on the Polar Prince, that was it. I mean, that was the implosion about 2.5 seconds after it happened, because that's the speed of sound through water. But they wouldn't have known, what it was. So they continued on, hoping, that it wasn't that. But the thing you have to think about is it's funny that the Coast Guard didn't know that thump was heard, and James Cameron did.
Yeah.
Or maybe they did know and they didn't say anything about it, because even if they had heard the thump, the Coast Guard was not going to give up. I mean, if your family was in that sub, you wouldn't want a Coast Guard representative to get up on, at a podium and say, "Hey, we heard a thump. We think they imploded, so we're not going to do anything." You know what I
Right.
mean? You wouldn't want that. So they were going to go full tilt no matter what until they found either could save them off the bottom or found the implosion. So
Yeah.
that's a controversial time for sure.
Yeah.
I wasn't like really following it, but everything to me just pointed immediately to it was an accident, disaster. If they had been stranded at the bottom, I mean, just the pressure down there, like I can't imagine that they could have stayed regardless of oxygen levels. I can't imagine that we would have been able to save them out of, I mean, I'm guessing they would just drag the submersible back up with whatever they went down to retrieve it with. But
yeah,
it just seems to me like the odds are just against you in those kind of conditions.
it is. But when you read the dive logs that got released prior to the final report, and then you read what the Coast Guard wrote in their final report, they had problems with every dive. They really had problems dealing with the drop weights and everything they had to do to become buoyant to float back up to the surface. So with all of the problems they had on all of those dives, it's not inconceivable that they could have gotten to the bottom and not been able to drop enough weight to become buoyant and refloat because they had so many problems with those type of systems. And, when you're down at, 3,800 meters and you're under all that pressure, really, it doesn't make any difference if you're down there for 5 hours, cruising around the Titanic, or you're down there for 4 days. It's the same pressure. If the hull's not going to give out, it's not going to give out. But here's the deal.
Even with the continuous pressure on it,
That's right.
I don't know.
It doesn't make any difference because it's static and uniform.
True.
So, but here's the thing, and something good may actually come out of this, and I've already heard about this. I think one of the rules going forward for submersibles, if anybody builds anyone new, that they're going to try to develop some kind of uniform standard grappling hook that has to be at the top of the submersible in the center of gravity. Because the problem with the Titan was there would be no way to grab it. So if you went down there with an ROV and they were alive and they didn't implode and you tried to lift them, that ROV would have had to try to manipulate itself to get around some portion of that landing gear.
Tether
because that would have been the only thing that you could have possibly, lifted it by. And you don't know, they wouldn't have known what size it is. They wouldn't have known how to clamp on. It would have just really been difficult to get underneath the sub, especially if it's sitting there in the sand on the bottom, and get some kind of remote arm or hook or something on it. So I think going forward, there's going to be a rule about having some kind of standard hook on the top. So if this ever happens again, it's easy to attach. And all of the big ROV companies out there that could possibly do a salvage or a rescue like this would know the specifications.
How much regulation is there on building a submersible? Like, is there a standardized like test that you have to pass? Because the documentary doesn't really, at least from what I can recall, doesn't really allude to like it has to go through these standards of testing. Whereas you think of like aviation, planes are tested frequently to make sure that they're airworthy.
Sure. And that's a great question. And you've hit kind of the major point of all of this with that question, is there are no rules. Being certified for a submersible basically is voluntary. You don't have to do it. So that's when they talk about being classed, that's what they talk about. They talk about these societies. Basically, they're private. They're made up of engineers who are in the sub community that you have to pay them to look over the systems of your sub to make sure it meets the specifications that have been and the safety standards that have been developed through time. But it is totally voluntary, and Stockton decided not to do it. He just decided not to be classed, and the reason is it's very expensive to do it. Even if you were going to do a spherical titanium submersible, like kind of the standard builds, it still costs, hundreds of thousands of dollars to have those classing societies go over every detail. The life support, the viewport, the titanium, all of those drop systems, they go over everything before they'll class you. And then you have to get reclassed like every year or two. And I think every 5 years, you have to tear it all down and have everything looked at again. So they had no classing specifications at all for a carbon fiber hull for occupants, a manned carbon fiber hull. So Stockton would have had to start with the classing societies, at the beginning. And it would have cost millions of dollars and probably taken 3 or 5 years to do it. And that's if he could do it, because that doesn't mean they would approve it. That doesn't mean they would class him. So he could go through all that time and go through all that money and not be classed. So originally, early on, he thought about it and he talked to the classing societies about it, but just decided there was no way he could get classed. So he just didn't do it. So there are no rules. The only rules that kind of oversee what's going to go on with a submersible or not is if you're going to take passengers. So if you're going to take passengers, you do get into the Coast Guard rules about what is a safe passenger vessel. But again, that was very confusing because there are no Coast Guard rules for what a submersible should be in terms of safety. They basically took the surface rules, that's that NAVIC 93 that they always talk about, and they kind of apply it to submersibles, but it doesn't really work well. It's like it's a square peg in a round hole trying to make that all get figured out. So that's where you get into the story, and we can talk about it more, about when they were diving in U.S. coastal waters, they were calling their paying passengers mission specialists. And the reason they were doing that is if you're a mission specialist and you're part of the crew, then you can say that your vehicle is not a passenger vehicle, it's an oceanographic research vehicle. And then all of those passenger rules don't kick in, and basically you can do what you want. So that's how they got away with it in coastal waters.
Yeah.
That's wild. I remember them touching on that. And
as a passenger, how do you sign off on that?
And they
they
showed in the doc, like they signed the waivers, and the waivers are they're like pretty extreme. It's
right.
And they're just like excited and sort of thrilled to be. It seemed like anyone that had been a mission specialist on the sub in previous dives on the 13 in advance of the half that failed,
right,
they all kind of described pretty candidly at the start, like, I did feel like honored to be on that. Like I felt like I was doing something. They sort of liken it to like the SpaceX exploration. They all had that. There's the one scene with that content creator, that diver guy, and he gets really emotional.
Yeah.
I think what is his channel? DL Mighty, I think.
Yeah,
is his, channel.
Yeah.
I remember having followed him when he first got his start on YouTube, and he would dive in rivers and stuff and collect little treasures that he found, people's sunglasses and whatnot. And so for him, that was like what SpaceX was doing with the Starship. What was that called? We all signed up for it jokingly.
Dear Moon.
The Dear Moon mission.
Yeah.
So it kind of gave me that vibe. He was getting this chance to do this incredible thing. And so I felt like they were a little, I don't know, just signing that waiver, that they were so free with it, because they felt and they trusted, and obviously Stockton had sort of some sociopathic behavior. Right? He was very charming, it seemed like. Is that right?
Yeah, no, he was a good salesman for it, and certainly the people who wanted to do it they had those personalities. I mean, that we're going to talk about that later. That was tapping into the market of what Stockton called adventure tourism. People who want to do expensive, exciting things like that, like, climbing Mount Everest or going on one of these space flights. Those are the type of personalities who are going to do this. And if you go way back in the history of OceanGate, which we'll touch on later, it was Stockton and his partner who started it, Guillermo. They had this idea to do this mission specialist thing from this company that's out there and is pretty successful called Earthwatch. And what Earthwatch started was this program where, and Guillermo gives the example in his testimony, where he says, if you want to go on a vacation, let's say to North Africa, and dig up an archaeological site, as a private citizen, you couldn't do that. So what Earthwatch does is they let these people pay, like, the last prices I looked at were like $3,500, and you can go dig an archaeological site, somewhere in North Africa, and that money, in a way, you're saying that you're supporting the PhD professor that's over this site. So it kind of gives you, the opportunity to do something that you think is fun, but you can also tell people you're doing something scientific. And on one hand, it's also a vacation, right? So you're supporting the scientists, the PhDs research by paying to go on this vacation, and dig in the sand, for a week. And that's basically how the mission specialist thing came about. You're paying this research project, which is Titan, to do surveys of the Titanic, to see, how quickly it's going to totally, melt away. Whether or not that's real research or not, who knows? I mean, it's marketing. I mean, how many temperature samples can you take at the bottom of the ocean? How many salinity samples can you take at the Titanic site? I mean, they were doing all that stuff, but that really was not real science. It was about the adventure tourism trade and eventually trying to be profitable.
Yeah. Yeah, they talked about that, I think, in some of these stories, and I know you reference it in the book as well, that it just felt like there was such a like a quick brush over the fact, like, oh, we're going down there to do these surveys. And then
Right.
I remember thinking, like, they've been doing these surveys for years. Like,
Yeah.
I mean, not to say that somebody else can't get in the game and do the research themselves, but like you said, Gordon, like, there's only so much that you can do in a way. It's been scanned before, right? But
Yeah,
interesting
and
nonetheless.
you can certainly do it better with unmanned ROVs now. In fact, they just released those pictures from, I think it was called the Magellan project last year, where they went down there with an ROV and took amazing resolutions of the Titanic, and were able resolution pictures, and able to put a 3D model of the Titanic to do it. You don't have to go down there with people to do what you need to do to survey the Titanic, long term.
Yeah, I found that was I don't know if you guys saw that, the newest documentary about the Titanic, and they reveal these images that Gordon's referencing, and they put it in like a
They panned it all together.
yeah, they panned it all
Yeah.
together, and they put it in like an auditorium, like an IMAX, and so you could walk up to it and you really felt like you were at it.
Yeah.
And
Wow.
it was there was a sort of like a little bit of an eerie irony there. Like, these people were going down there to see this thing, and then now you have this incredible scan where you can go up, and I understand it's not the same, but you can get just this crazy granularity.
Wow.
You look like you're like down to the cloth and the
Really?
little dishes and everything. Yeah. Because they did internal scans, they did external scans,
Yep.
and it's just wild that all of that happened since Titan's tragedy,
Right.
and yeah, it just is like, oh, that
Yeah.
it's a really tragic story.
Yeah.
This is a head scratcher for me. I know there's a big fascination with the Titanic, but if I was given the choice, get in a submersible, go see Titanic, or go to the moon, see, the lunar lander, that's a no-brainer. I'm going to the moon.
Yeah, let's go to the
And I don't do well with tight spaces to begin with. The submersible just creeps me out to begin
Yeah.
with, and I just to see Titanic. Okay, it's a sunken ship. I don't get it. But there is this aura or this fascination about it that, some people just have.
Yeah, being that far in the ocean too, and like I've actually, since the accident happened, and I'd like to get to the actual presentation here, but since the accident, like I've had like moments where I've like imagined myself in that position and like
Hands get a little sweaty.
actually like fearful of, the people that were there, fearful for them and sad for them. That had to have been like absolutely terrifying when it was happening. But
I would just pray that you never knew anything happened if you're in
Yeah.
that thing.
Yeah.
That was the sad part, right? It seemed like after what we now know, they sort of did. They heard these cracks and these crinkles. I'm sure you'll get into it in Death Gordon, but like these, what did Stockton called it? Like seasoning, like carbon was seasoning, and you're like,
Yeah.
all of us ride carbon bikes, and when it cracks, it cracks. Like it's broken.
Yeah, it's done.
Yeah, that happened a lot in the Bahamas. I think that the implosion, I believe it when it happened, it was instantaneous. So I don't think they felt anything. But yeah, so one thing, just to go back to the space analogy, I forgot the number, but if you want to go into space, the dangerous thing obviously is launching, right? Because you have all this energy to reach the velocity you need to get to orbit. So you're basically sitting on top of a controlled explosion. So, I mean, that 8 minutes or 8.5 minutes that it takes to get into orbit is the dangerous part. Once you're up there, your capsule only has to keep 1 atmosphere of pressure in, right?
Mhm.
Well, when you go to the Titanic, you have to keep, I think it's a couple of 100 atmospheres of pressure out for the whole time. So it's a whole different ballgame. I mean, if you look at the lunar module, which you brought up later, I mean, basically that outer skin was made of very thin aluminum, a little bit thicker than aluminum foil, but not much, because it doesn't take a lot of engineering to keep 1 atmosphere in a capsule. It takes a lot of engineering to keep a couple of 100 atmospheres out of a capsule. So it's very, very dangerous to go to those depths, incredibly dangerous. I wouldn't have the nerve to do it.
No. Have you been in a submersible at all?
I've never been underwater like that.
I've been to the only, it wasn't underwater, but the only submarine, technically, it was the USS Silversides in Muskegon.
Oh, yeah.
It was a Boy Scout, and we went and spent the night on it. But we didn't, obviously, it was a World War II sub. It wasn't going underwater.
Right.
Decommissioned, just sitting there. But even to just get a sense of the way it's designed, right? It's the design of it is quite different than a ship. And yeah, there's something nerve-wracking when you see these videos from the documentary or these photos that you've got in your book of just people, citizens that again are being they're over leveraging that citizen science role.
Right.
The company is, and they're just getting in there. You're like, they take their shoes off, they walk in there with their sock, and you're just like, oh my goodness.
Yeah. And then
they bolt in.
And then you get bolted in, and there's no top hatch. It's just crazy.
Yeah. My claustrophobia would just kill me.
I felt terrible for that girl who was like she did the bolts.
Yeah.
She was like, oh man. I mean, there's some real trauma there for her, I'm sure.
Hopefully they charge the PlayStation controller.
Yeah.
Bolt you in.
So, you bring up a good point with that when you talk about the girl who did the bolting in, and let me just say it right now so I don't forget. Certainly the families of the 5 people who died are impacted forever. It's a terrible tragedy. But this Ocean Gate tragedy has traumatized a lot of people who have worked for the company and will for a long time. And I've been in touch actually with some of them. And it's hurt a lot of people. People who were involved with this are having a tough time just dealing with it, because a lot of people think they could have done more to stop it. A lot of people knew the people who died. It's very complex. So it's really impacted dozens of people, more than the 5 families who lost a loved one on it. And that's something that doesn't get talked about. But I've been in touch with some of these people, and it's really tragic for them too. Even though they're alive, it's impacted them, a lot of people.
Yeah, certainly a lot of emotion.
Yeah.
And yeah, that sense of guilt. Naturally, there's that probably an inherent sense of guilt. It would be really, really challenging.
Yeah.
But
It's brutal.
Yeah,
It's
definitely.
brutal. Yeah.
Do we want to transition to some of the
get into it.
slides that you've
Yeah,
prepped?
let me go quickly through these slides, and then maybe that will spur some questions by you guys about more of the engineering details.
Yeah, sounds great. We'll get started, and then maybe in about 10 minutes or so we can take a break. So we'll do some slides, and then at that talking point, that'll be a perfect spot for a Berg break, what we call it.
Yeah, that's fine. And
half one
these are
and half
not
two.
that long. I didn't want to give a long talk. I just wanted to kind of start the conversation. So I'm going to share
Right
my
on.
screen. Okay.
Let's do it. Yeah, I'll add it to the stage, and we'll see all of this interesting information.
You got it?
Yep, we got it.
Okay. So let me just go through this quickly. I know it's a lot of words, but I'm just going to kind of speak it quickly. A lot of people don't know some of the deep history of starting OceanGate. So it started in 2008 with a partner, Guillermo Scholine. And the original plan, you have to realize that the original business plan had nothing to do with going to the Titanic. Okay. It was about researching the deep oceans. However, Stockton and Guillermo were entrepreneurs. So they saw this as a business opportunity to lease deep submersibles for science, exploration, the oil and gas industry, fishery management, and things like that. I mean, they wanted to make money off of this, and they thought it was a niche that they could take advantage of, because there are very few deep diving subs in the world. At the time, there were probably only 5 or 6, and they're all owned by governments. So what they used to talk about is if you can get to 4,000 meters, you can get to about 65% of the ocean. If you can get to 6,000 meters, you can get to about 98% of the ocean floor. And that was their goal, to build subs to get to 6,000 meters. And their original goal was to have 5 or 6 of these subs stationed all around the world that could go to 6,000 meters. But to be successful to do this all around the world, they had to figure out a different way to launch the sub, because you could not be reliant on these big ships with an A-frame that launched these heavy titanium subs off the back of the ship. Because in that case, these big ships are part of the expense. They're expensive to keep. They use a lot of fuel, so they're expensive to drive around the world. And you're linked, the sub is linked to this mothership, which is very limiting. So that's where Stockton came up with the LARS concept, the launch and recovery system. Because now, if you could have a lightweight sub on this LARS, you could tow it around by any boat that has enough horsepower to just tow it around. And then you can launch it from the LARS. So to do that, to make this financially viable, they had to have a light sub and a LARS, and the sub had to be lighter weight. So therefore, that's how they got into carbon fiber, because big titanium subs would be overweight. Okay. Then they wanted to make all the parts small enough so you could take it apart and you could transport it on a flatbed truck. So the Titan system, the Titan could go on a flatbed, and then the LARS would split in half. So they could put a half of a LARS on one flatbed and a half of a LARS on another flatbed, and you could drive it anywhere where you had roads, okay? So they wanted to make it small enough to transport it around. They were actually smart at the beginning. They didn't start out trying to build the sub. They bought 2 used subs, the Antipodes and the Cyclops 1, and they learned how to work subs and what you needed for sonar and ballast and all that stuff. They learned all about that. But they had problems immediately, because as soon as they started to try to dive in U.S. coastal waters, all of the U.S. coastal waters are divided into sectors that have a sector commander from the Coast Guard. And the Coast Guard has strict rules for passenger vessels. And most of these commanders in the sectors had no experience with subs. So they didn't know what to do. They didn't know how to give them permission to dive. So that's where they started this whole routine of paying passengers being called mission specialists. Because if you did that, you could be considered an oceanographic research vessel, and you didn't fall under the passenger vessel rules. And the clients were paying their money to OceanGate, but it was quote unquote to support science. But Guillermo was doing all the paperwork. He was the guy who was talking to all of these sector commanders when they were trying to go to San Francisco and Miami and a couple of places they did it. And he realized it was a disaster. It was just difficult. So he has never said it publicly, but I think Guillermo quit because he was smart enough to know that this was not going to be financially viable. Let me try to advance. It's not advancing. Okay. Now, this is a quote by Guillermo, and this is in his testimony. And the Coast Guard asked him, did you ever go on an expedition, or did Stockton ever invite you to an expedition? And he said he did. He said, but this is his quote. He said, the reason I didn't go is because neither Stockton nor I were driven by tourism. Okay, so he's saying this at the hearings. We were never motivated by going somewhere that people had already been before. The reason we got into this was because we both wanted to explore. We wanted to not only explore ourselves, but create technologies that would allow other explorers to explore the ocean. So listen to this. So going to see a shipwreck that had already been well documented and that a bunch of people had already gone to, that didn't excite me. It didn't excite Stockton. So it's amazing that it transformed itself into a Titanic tourist industry. But this is why. As Guillermo was leaving, they were shopping around for sub builders. They wanted to build a 4 or 5 passenger sub, and it had to be lightweight, but they couldn't find a supplier who could build it for them. So Stockton wasn't giving up on the business idea. And he also, at this point now, after talking to all these sub manufacturers and the classing societies, he saw it as a challenge to prove all of these guys wrong. So they learned enough about subs by shopping around that they thought they could build their own. But he also realized he couldn't run this business in U.S. coastal waters due to the restrictions. And there was not enough money to be charged to make money in science, the oil industry, and fish management. So he had to change the business model to adventure tourism, like we talked about before, like paying $75,000 to somebody to go climb Mount Everest. And he had research that showed that adventure tourism trips that were exotic, trips that cost over $100,000 per year, was a $4 billion a year industry. So he wanted to tap into this adventure tourism market because this is about making money at this point when going to the Titanic. He also figured out that the Titanic is in international waters and he could sail out of Canada, so he'd have to deal with the Coast Guard. And what happened was he wanted to do his first Titanic dives in 2018, but the sub couldn't get ready. Then they built the sub and they were trying to get it ready for 2019, but that's the one that cracked in the Bahamas. So then they had to build a new sub. Then they built a new sub and had to deal with everything that had to do with COVID. So the first time they were actually able to get the expedition, even though they wanted to start in 18, was in 2021. You need to know kind of the engineering history a little bit to put this in perspective, because these guys were all beat on by Stockton, except for Phil. Phil was kind of a meek old guy, so he never argued with Stockton, so I don't think he took any grief. But Tony Nissen was the first director of engineering. He testified. He gave great testimony. But he got fired in 2019 after the first hole cracked. He kind of got blamed for that. Then the second director of engineering was Daniel Scoville, and he's the one that got the second hull up and running for Stockton for the 2021 season. And at the time, Phil Brooks was there, but he was just doing software. But then after 2021, Dan got beat on by Stockton just like Tony Nissen did, so he left or got fired. So Phil Brooks was appointed as the director of engineering, even though he had no background in mechanical engineering, no background in subs, no background in carbon fiber. Stockton just promoted him to the director of engineering. And then he got tired of it and he left in 2021. So for the 2023 season, they had no director of engineering. It was basically just Stockton out there with the Polar Prince. Now, let's just go over some of the details quickly of the two hulls. So this is a picture of the cutoff end of the first hull, and this is in the Coast Guard hearing documents, and this is the second hull, okay? So this hole, the first hole, was based on the Boeing feasibility study. And Boeing started out thinking that it had to be 9.3 inches thick. Then they kind of went down to 7 inches if the fabrication of the carbon fiber was perfect. But to do that, they strongly recommended having cross plies at 45 degrees, not just having plies that are wrapped around the sub and plies that are longitudinal along the long axis of the sub. That's what OceanGate eventually did. They ignored the recommendation for 45-degree plies. So Boeing did that first study, but basically OceanGate learned from it, but kind of ignored things because Spencer Composites were the engineers who designed the second hull, or the first hull after the Boeing feasibility study. It was originally planned to just be 4.5 inches thick, but Stockton increased it to 5 inches just to kind of be safe. The original goal, like we said, was 6,000 meters, or the hull should withstand 8,800 psi. In this hole, the carbon fiber was laid down all at one time. All 5 inches was laid down, and then all 5 inches was cured at the same time. Before they built the full hole, they built 4 1/3 scale model holes to test in the little chamber at University of Washington. None of those models made it to 8,800 psi. One failed at 42.
Is that the equivalent of 6,000?
It is.
Yeah,
That's right.
6,000
6,000
meters.
meters, you have to get to 8,800 psi. But they failed at 4,200, 6,000, 4,000, and one made it to 6,500 psi. The acoustic monitoring that Stockton always talks about was only installed and tested in these last 2 holes. So he really had very little experience with what acoustic monitoring was going to tell him. And so despite no validating data of the fabrication, Stockton went ahead and built the full-size hull, even though he didn't have any proof of fabrication from the test hulls. They didn't do any chamber testing at the Deep Ocean Test Facility. They went right to the Bahamas and tested it 3 times at different depths by dropping it on a string. They did get down to 4,000 meters and it didn't implode. And then there's that famous solo dive by Stockton where he heard all of the popping and all of the cracking in the hull that was in the Netflix documentary A Lot. This is the hull that got damaged by lightning. If you hear about that, that's this hull. This is the hull that made all those popping sounds in the Bahamas. And then this is the hull that cracked in 2019. So then you compare that to the second hull they built. The second hull, the engineering for that hull was a company called Collier Aerospace. And this is really interesting because Collier was not mentioned at all in the hearings. And this was driving me crazy because I knew somebody had to be helping Stockton, but they didn't say who it was. So we didn't find out about this until the final report came out, in the beginning of August. But anyway, this hull was fabricated by Electro Impact in Washington, but Electro Impact couldn't cure it. So it had to be transported about an hour north on a flatbed truck to a company called Janicki Industries where they did the curing. So each one of these 1-inch layers was laid down separately so they could prevent wrinkling when they cured it, although it didn't work perfectly. And then they would drive it up to Janicki and cure it. Then they would put another layer down, drive it up to Janicki and cure it, put a third and a fourth and a fifth layer down, and every time they had to cure it. And this little white line you see in here, this is a film adhesive that they would lay on the previous layer to glue these all together. So this had never been done before for a thick laminate in a sub. Each layer was not as smooth as they wanted it to be, so there were wrinkles on the top surface. So they had to grind down those wrinkles in the carbon fiber so they would make this nice and flat for the next layer of film adhesive to lay on it nicely. They did test this in a chamber in Maryland. They did 4 simulated dives to Titanic depth, so they did put this in a pressure chamber. Then they brought it back to Washington, finished building out the inside, tested it in the harbor there 13 times. I think their deepest dive was 130 meters. And then they trucked it to Canada for the 2021 season, where they started their first deep manned dives. So I'm just going to go over a couple of the most controversial dives, right? So they get to Canada. Their first dive over the Titanic site is dive 61, and this is when the front dome fell off. Just incredible, but the front dome falls off while they're dragging it back onto the Horizon Arctic because of the trauma of kind of dropping it from the crane. So dive 62, they fixed this, they fixed the hinge, they bolt it back on, and a couple of days later, they have the nerve to dive again, and they do get down to 1,800 meters, but they had some problems with the thrusters, so they had to come back up. Dive 63 is the first dive that got to Titanic depth, but they missed the wreck, so they didn't see it, although OceanGate advertised this as the first successful dive. They did get down to the bottom, but they didn't see the wreck. Dive 66 is another dive where they missed the wreck. And I've been in touch with actually this mission specialist, and he sent me this diagram of their tracking. And this blue line is the tracking of the Titan. And you can see how they threaded the needle through the debris field, but missed the stern and missed the bow because it's really hard to navigate down there. And then,
what would have their visibility been like with the lighting and everything?
That's a great question. So I think their visibility in front of the sub with lighting may be about 50 meters. And they had a sonar that could go about 100 meters because they didn't buy the most expensive sonar. So the way they would navigate down there, and this is crazy, Antonella Wilby testified because she was a contractor in the 2022 season, and she was the one that was responsible for doing this tracking. So what was crazy, here's the way they would do it. The Titan would ping to the Horizon Arctic about every 5 minutes. It would send a ping, and along with that ping would be longitude, latitude, and depth. So Antonella, I'm going to go back one slide so you can see. So the Antonella would have to physically type those numbers into an Excel spreadsheet. And that Excel spreadsheet would then get fed into a little program, and it would generate this little dot. So these little dots were on a map that they had on the Horizon Arctic. So they could tell the Titan, you've got to go, 10 degrees to the northwest, because they couldn't see. So they would be down there trying to turn the sub the direction that the surface told them to go. But they only got information every 5 minutes, and it wasn't very good, so it was really hard to navigate. Antonella, who had a lot of experience with submersibles, was astounded by how bad it was. And that's why they fired her. They kicked her off the ship after that mission, because she was complaining about how stupid the process was. Then, of course, Dive 88 is the big controversial one, because this is the one where they heard this big bang, this huge loud sound right as they got to the surface. And what's controversial about this is that, Stockton blamed it on the sub repositioning itself in the landing gear cradle. That's what caused the noise. But what's really suspicious about this is Phil Brooks was the one who was responsible for printing out this data. So he printed out this data and he showed it to Stockton. So Stockton saw this spike, but he also saw the shift in strain gauges. So this was evidence that the hull had shifted, something had gone on, and he was not upfront about that to anybody, and they continued to dive despite the strain gauge change that he knew about. So despite what happened on Dive 80, they dive on Dive 81, they get away with it, and that season they get away with 82 and 83. But I didn't put it in this talk, but it's in my book. There is other data in the strain gauges from these dives showing that with each dive, the hull was changing.
How much inspection were they doing after each dive on the hull?
So that's a good question. You can't see the hull. So on the outside, it's covered with rhino liner to prevent water intrusion into the carbon fiber into the epoxy joint at the rings. And on the inside, there is that fiberglass insert that slides into the carbon fiber hull, and it's spread out from the carbon fiber hull by these little spacers that are about an inch thick. So with a flashlight, you could kind of look down the side of the hull between the hull and the liner, but you really couldn't do anything. So you couldn't examine the hull. But even so, with that 5-layer carbon fiber hull that I talked about, that delamination that happened, which made that noise on dive 80, probably was not on the inner surface, or certainly not on the outer surface. It was probably in between one of those layers. So even if you could pull out the insert and look, which you couldn't do on the ship, but even if you could, you wouldn't have seen it. It would have been inside the layers.
Wow.
So then this big controversy happens in between 2022 and 2023. After they finished dive 83, Stockton didn't want to pay to bring the Titan back to Washington. So he left it on the dock in Newfoundland in the winter up to about February before they moved it inside. So the poor sub went through many days of freezing and thawing cycles. And we all know how bad that is. If there was any water intrusion anywhere into this carbon fiber or into the epoxy joint, that would have weakened things. So that was hugely controversial. And I don't know how he could justify that.
It's like treating it like a Honda Civic.
Yeah,
in
exactly.
Michigan in the wintertime. Yeah.
I know.
Man.
And then the other controversial dives, there's dive 87. This is a dive where the Lars malfunctioned because they didn't turn a valve correctly. So they went down, 10 meters to try to launch. And, the Lars would go under the water 30 feet, and then the Titan would take off from the Lars. But they had a problem with the ballast system, the variable ballast system. So they had to resurface. But when they resurfaced, a valve was not set in the right position. So when they pumped air into the Lars, they pumped it into the front 2 chambers and one of the back chambers, because it had 4 separate chambers, but one didn't purge the water. So one of the aft chambers kept its water in it, which kept the back of the Titan down and the front of the Titan facing upward. And because it's only pinned down at the back, with each wave, the Titan was coming off the platform and then slamming back down, coming off the platform and slamming back down. The testimony from the Kroyman couple who was on this dive is amazing. So think about that. You guys know enough general physics to understand if you have a 3,500-pound dome on the front of the Titan and it's slamming down and hitting the Lars, you can just imagine the forces that are pulling on this upper glued joint, okay? Because it's like a hammer, like it's like a big sledgehammer. So getting to the Coast Guard final report, there's a couple of things I want to clear up. The Coast Guard final report dispelled the rumor that OceanGate used out-of-date carbon fiber from Boeing. Remember, that was spread around early after the disaster. That's completely wrong. OceanGate bought new carbon fiber from a company called Toray. That's the system they use. It clears up the fact that the second viewport that was used during the Titanic excursions was not the original viewport that had the low depth rating, the hybrid viewport that Tony Nissen designed. They did buy a new domed spherical sector viewport that would have been certified to 4,000 meters, but they did do something on the cheap here. They didn't want to pay for the final certification. So the design was correct, but it didn't really have the stamp of approval. The other thing that drove me crazy, the final report cleared up the fact of when they welded lifting eyes on the second hull's titanium rings. When Tony Nissen built the first sub, he did not want the sub lifted by the top, by the rings. He wanted the sub always lifted by the landing gear so that the pressures wouldn't be transmitted directly to the sub. They would be taken on by the gear. But if you look at pictures of the first Titan sub and then the second Titan sub, you will see that the second Titan sub has these cutouts at the top of both of the rings on the top where they could put crane rigging to rig the Titan. Tony said, absolutely do not do that, but they did it between the two versions of the hulls. What always bothered me was I didn't think they would be stupid enough to weld titanium lifting eyes onto the titanium rings when it was already epoxied to the carbon fiber. But that was never made clear in the public hearings. But when Dan Scoville testified privately, he didn't testify publicly, but he testified privately, and the Coast Guard released his transcript. He explained that the lifting eyes were welded onto the rings when they were off the sub, and then they were glued on the sub later. So that was something that bothered me, and the final report cleared that up. But anyway, the final report has a lot of information in it, a lot of really, really interesting details for somebody like me. But basically, the bottom line is there was nothing really new about the point of failure. I mean, based on the testimony, we could all figure out what it probably was. So the Coast Guard leaves it open-ended as either being a hull collapse inward due to buckling failure, and I'll talk about that in a minute, or failure due to water ingress into the forward epoxy joint, okay? Now, there's a difference. This word buckling failure is important because there's a difference between the hull imploding from the pressure in the middle. Like all of us have seen these animations that were on the internet of the hull kind of squeezing like an hourglass and then, blowing up into a million shards. That's not what happens in buckling failure. In buckling failure, what happens is a weak point continues to get weaker until it gets to the point where they use the term out of roundness. It's not the same shape as the rest of the hull, and that makes it even weaker under those kind of pressures. So then that gives way. So it's a collapse of a certain portion of the hull. It's not a fragmentation of the entire hull. And I just want to show these quickly in case we want to go back to dives. I did a little legwork. The Coast Guard released graphs like this that showed the depths of the dives for the V2 hull, the second hull that went to the Titanic. Well, I took all of their data from the dive logs, and I did the same thing they did. I put it in an Excel spreadsheet so you can see what the dives did. A lot of people didn't realize that OceanGate numbered its dives from number one, when they first started. If they put the thing in the water in Everett, Washington, they called that a dive. So they called that dive number one. So these are all dives that they labeled as successful dives, but they may have not gotten further than 10 feet under the water. Then we get to the Bahamas dives, and I'll show you a little bit more about that. I mean, no, these are the string dives. These are the 3 string dives. Then the Bahamas dive, and then the last dive with Carl Stanley. So they get to the Bahamas, and they drop the Titan on a string 3 times, and they get down to 4,000 meters, and it doesn't implode. Then Stockton does 2 solo dives. One dive, they didn't have the ballast calculated correctly, so he couldn't break 2,400 meters. And then the next dive, he did get down to 39. And this is the dive that's all over Netflix, where he talks about all the popping of the hull. Then they did a little bit more weight testing. And then dive 47 is that dive with Carl Stanley, the guy who runs the guy who runs the sub out of Honduras. So he got a lot of press, post tragedy. So that's his dive. And then that's when they find out, 48 is when they find out the hull was cracked. They did one more little dive back in Everett, and then that hull was done. And then here's the Coast Guard dives that were in the first presentation. And so they bring it dive 50. These are all dives that were done with the new hull back in Everett, Washington, just little dives up in the Sound there or in the Bay. Then they bring it to Newfoundland in Canada, and they start manned dives with dive 61. The first season goes to dive 70. Then the second season goes 71 to dive 83. Dive 80 is right here. That's the one with the loud bang. Then they store it outside That's where they have the freezing issues. They have 4 aborted dives in 2023. Dive 87 is that Kroiman dive where it's banging up against the Lars, and then it's the final fatal dive. And that's it. That's all I wanted to talk about. And now we can just answer questions about any of the technical details you guys want to talk about. Again, the landing page for the book, if anybody's interested, is www.titandives.com. And my 13 Titan videos, which are really detailed, are on my YouTube channel, which is my Solar Eclipse Timer YouTube channel. But right now, the first part of it has to do with Titan, but pretty soon I'm going to get back into eclipses. So that's all I have to share with the presentation.
Very nicely done.
Incredible amounts of work on top of it, just to even analyze the reports, right? Like this newest Coast Guard report, the final at the beginning of August, to decipher that and be able to share it to an audience like this is really incredible. So I appreciate the data, and I'd love to open it up for discussion. And maybe we'll take a quick break, and then
Sure.
I certainly want to ponder on a couple things and be able to ask a few questions, because this does shed additional light, I think, more than what the documentaries provide you, right? Like there's the thing about the Collier, what was the name of the company?
Collier Aerospace.
That's they just decided not to talk about that. It's wild, and it comes out in the final report. So
and I wrote my book before the final report came out because I knew I could make the same final conclusions that they did, and I did. My conclusions were right on. But learning about Collier Aerospace was amazing because basically Collier gave Stockton great analysis of his hull. I mean, Stockton had confidence in that hull based on the finite element analysis that Collier did. I mean, they were way wrong, but they told Stockton it was good to go.
Wow. It's incredible. We'll take a quick break. Our Berg break, sponsored by Underberg, up there in the top right corner. We'll go ahead and be back with you to talk all sorts of things, deep dive into Titan's Submersible, all the questions that we have following this break. So I'm going to go ahead and pause this, Gordon, and then we'll meet back here in just a bit.
Okay, great. Thanks.
And we're back from the Berg break into the second half of episode 87, featuring Dr. Gordon Telepun, speaking about his expertise in the Titan Submersible with his new book, Titan to the Titanic and Back 13.5 Times, Stories About Bad Decisions Made. We certainly heard about a lot of bad decisions. We were talking about it on the break, and we were blown away by some of the things that we heard. Yeah, it's incredible. But yeah, the Berg break, sponsored by Underberg. We were just talking to Gordon about this lovely product, a little bottle. I'll get it up close on the screen.
Yeah, get it in there. There you go.
Just a little green glass bottle, or brown glass bottle with a green top. Wonderful product, Herbal Digestif, and we are grateful for their sponsorship of our show and our cycling team. So next time Gordon finds some Underberg in Alabama, he'll have to pick some up.
Check your local, not like a big retailer, but go to a kind of a specialty food and beverage place.
Okay.
They'll have it.
Yeah, they usually have it at places like that. But yeah, we were, again, talking on the break, taking a moment to reflect on some of the things that you shared with us. And there's just so much more. It's like filling in the gaps, right? I know you've described that with your book. It's a great opportunity for people to take that next step and fill in the gaps that the documentaries just don't either have time or the desire to fill. And yeah, some incredible things. I guess maybe, did you guys have questions? I think I had a couple too, but I'll have to
well, I think
form them up.
The one thing that we were all talking about on the break, and we kind of talked about in the first half before you got into the book, is just not one of us would have the nerve to get into something that small and have the door bolted behind us. And just I could see, we live by Lake Michigan, going out into 40 feet of water. There's still sunlight. You could kind of explore the floor of it. But to me, it's just such a scary thing to be bolted into a submersible like that. And then just, you're not it's not like you're getting a great ride on the way down. It's just darkness.
Right.
And then you're hoping to be able to track down Titanic, a sunken ship. I just don't understand the allure for me personally. I would be terrified. There's no way on earth I would get in one.
I can't imagine being in that small sub with 5 people in there, and then a lot of people don't. Well, let me just go through it a little bit. They may not understand how this actually works. When you build a sub like this, you're actually building it to be almost neutral buoyancy, right? And so they put on enough weight to sink. So you're sinking as a free fall. You're not propelling yourself down there. You're just sinking. And they usually have about a couple of 100 to 300 pounds of extra weight to make themselves positively or negatively buoyant. So you're going down. And then as they get to the bottom or close to the bottom, they drop weights to slow down. So they become a little closer to neutral buoyancy. And that's why you hear right after the disaster, everybody was talking about the last message from the Titan that they typed in their little modem was drop 2 weights. And initially people thought that was some kind of emergency or all this other stuff, but it really wasn't. That's the normal procedure when you're getting close to the bottom, is to drop a couple of weights to slow down, and then drop a little bit more when you get closer to the bottom, and then you hit the bottom. Hopefully you can thrust a little bit upward so you don't hit hard, and then you're on the bottom, and then you start to look for the Titanic. So it's 2.5 hours in this sub with 4 other people. There's 5 people total, and you're just dropping down through the dark water column. I mean, I guess you make small talk. There's nothing much to do. The pilot's doing most of the work, and there's really nothing to do because he's free falling also. Now, another little thing that's interesting about getting to the bottom is 2 things. First of all, up at the surface, they have to position themselves close to the Titanic, but you don't drop down over the Titanic. You have to kind of lead yourself, because you have to know what the currents are for that particular day. So you drop down away from the Titanic, and there's also international rules about not dropping drop weights on the Titanic or even in the debris field. So they aim to drop down about 300 to 500 yards from the Titanic debris field on purpose, because there's international rules about that. So they have to drop down far away from the Titanic, and then they have to find it. That's just the way you do it. So there's say what you want about Stockton. He did some really bad things, but what he figured out is not easy to do. I mean, it's really, really hard to do what he did to get down to the Titanic at all. Most of us couldn't figure it out, and those guys did it. So have to give them a little bit of credit.
Yeah, there's the scenes in the documentary. Those they made it down twice, right?
To
the Titanic, to the actual wreck.
No, they made it down 13 times, but I think 2 times they missed the wreck. They never found it. So dive 63, and I know dive 66 because I've been in touch with one of the mission specialists from dive 66. And then one time they only saw the stern. They never got to the bow, and everybody always wants to get to the bow. So I think about 10 times they did get to the bow.
Yeah, it's incredible that can't be dismissed. Certainly, like in the documentary when they show the scenes through the porthole,
right?
The view hole. You do get that sense of like, wow, that's pretty incredible. But still, like at what cost, right? Clearly, it ended in disaster. Yeah. This string of bad decisions just eventually found its way in the most tragic way.
Right.
The truth of it all sort of came out. Yeah, terrible.
I have a couple comments and just things that I think about with the whole the business of using carbon fiber for this whole thing, and not really like from the documentary that I watched on Netflix, it didn't seem like the the glue that they were using, like the way they were applying the glue, the way that they were assembling it was very controlled, or I don't know, if maybe it was just kind of sloppy. It just
Very
seemed like.
warehousey.
And then the other thing too is like through the whole process of all the tests and all the test dies that they have done, they have this acoustic system to catch failures, but it didn't seem to me like there was a single time they tested it where there weren't cracking or popping signs of failure the entire time. So I would sit there and think, is carbon fiber the way to go here? I know we're trying to go lightweight and portable and have it be something that we can have 6 of these subs throughout the world that are easily launched, and you don't need a big ship to do it and things like that. But the entire process, all the way through from start to finish, V1 and V2, like there was never a time where there wasn't popping. It seemed like, from what I saw and what you just went over, it seemed like there were always, I mean, in any time that's popping, I mean, I know that they can't really physically see maybe where the cracks or the pops were taking place, or where they were located because of the cover of the hole and everything. But you just think like, yeah, anytime you're hearing a pop with carbon fiber, that's a failure of some kind. And the more you do it, the more it's going to weaken as you continue to dive, especially at the lower depths. But it just kind of like boggles my mind a little bit that they continued to pursue the carbon fiber plan. And I don't know, it just doesn't make any sense to me, because the writing was on the wall the entire time. Like, this thing is cracking and you're going that far down. At some point, if you're not doing a scan of the hull or anything like that to see exactly how far in the cracks were or where they were located, you're kind of just ignoring. You have these tests and these alert systems, but you're not doing anything with it. It's just, it kind of doesn't make any sense.
Yeah, let me bring up 2 points about that and clear up some things. So when you talk about that classic video that is on the internet about them gluing the titanium ring to the carbon fiber hull, the sloppy one where there's guys up on step ladders kind of slopping on the epoxy and then they put the ring down. That's the V1 hull. That was the one that was designed and built by Spencer Composites, and that's the one that Tony Nissen is in the film, and that is terribly sloppy. Believe me, it's actually frightening. Now they did the second hull the same way, except I think they did it in a cleaner facility, and they were more exacting about preparing the surfaces. Even though they reused the titanium rings. They cut off the old carbon fiber and then they milled out the carbon out of that clevis, and they actually had to take a little bit of titanium to do it, to get it clean, and then prep it to get ready to glue again. So the gluing was done the same way both times, but perhaps under better condition the second time. Now, the popping thing, all of that popping that was very dramatized in the 2 documentaries, especially the Netflix documentary, really has to do with the first hull. The second hull was remarkably quiet. It really was. It did not have the popping like you see in that documentary, which is the V1 hull. Now, there was one big kind of, they called it like a ruler slap type sound. I think it was in one of the dives that was in the 60s, but nothing kind of ever became of that. And then, of course, there was the big pop in dive 80. But the second hull was not making the noises like you saw in the Netflix documentary. And in fact, I don't know of any mission specialist in the V2 hull that has gone on record and talked about that kind of popping. The second hull, I think Stockton had a lot of confidence in the second hull because it wasn't making those noises. Now, the other thing you have to realize about the acoustic emission system is the acoustic emission system was picking up like random noise like all the time, but they had to set a level of all those random noises that they would call a hit. Now, when Phil Brooks was initially doing it, I don't remember the exact numbers, but he wanted like 2,500 noises to be a hit that would come up on their monitor as something going on. Well, that was just randomly chosen, but Stockton wanted it to be 10,000. So you see, if you increase the number of little noises that end up being a hit that you see, and you make that level so high, you'll think your hole is perfect because you're never going to see a hit because you've set the threshold so high. They actually ended up making it 5,000. So 5,000 little noises became a hit, but it was totally random. I mean, it was totally random. And that's what Stockton talked about with seasoning the hole, and what they call the Kaiser effect is when the hole goes down under pressure, it's going to get squeezed. And there are little carbon fibers that might pop, or there might be a little matrix that pops. And that's why he called it seasoning the hull. So if you go down one time to 2,000 meters and you hear this popping, between 1,500 and 2,000 meters, and the next day you go down, all of those fibers that released their tension the day before should not do it the second day. That little area of strain has now released itself, right? So unless it's going to propagate to the next neighboring fibers, the next day it should be quiet or quieter. And that's what, Stockton was relying on. And that's why the testimony from Boeing was so important, because picture what's going on. You have the hole that's wrapped with carbon fibers all the way around. And then you have carbon fibers that are laid along the axis of the hole. So that's called the zero. Stockton refers to it as the 090, layup. Well, Boeing wanted a layer in there that was at 45 degrees to the 0 and the 90. And the reason was because Boeing knows carbon fiber. The reason is if you have a fiber that pops, like on the one that's circular, if you only have a 090 layup, the neighboring carbon fibers have to take that extra load now, or the ones that are 90 degrees to it have to take that extra load. But if you have fibers that are at 45 degrees, you've got more fibers in the area that now can distribute the load from a potential weak spot. You understand? And Stockton, he looked at that the wrong way. In fact, I'm doing a YouTube video right now where I'm listening to his the taping of the meeting where he fired David Lockridge, and he talks about the fact that Boeing didn't have the software, or didn't have what they call the allowables to predict the 090 layup. So that's why they kept on wanting them to do the 45 degree layup. But he missed the point. Boeing was doing that because that's another way to get the load to be distributed if you have a problem area. The other thing that Stockton missed, and he talked about it in his GeekWire talk, and Tony Nissen talked about it in his testimony, they always looked at the hole in the ocean as it's going deeper, as the pressure is symmetrical all the way around. And then Tony said that. He said that's the beauty of subsea vehicles, that the pressure is symmetrical all the way around. But what they forgot is the pressure is not symmetrical when you're on the flat bed of a truck, or when you're being lifted up by the lifting eyes, or when you're getting beat by going up and down the ramp on the Horizon Arctic, or when you're getting pulled through the ocean by the Polar Prince for 3,000 nautical miles. You don't have symmetrical compression on the hull. In those situations, you do have torsional moments, and they missed that. And that's why Boeing thought they should have 45 degree plies, which they didn't do.
I'm not an engineer. Self-admittedly, I'm not very, very technically savvy.
Nor am I.
But the way you're explaining it to me, that makes sense. When you're talking about, the amount of, you said it was 8,800 PSI of
Correct.
pressure. Like, that just makes sense to me. You don't just have 0 and 90. You throw in a 45, or you stagger it to distribute it in all directions.
Absolutely.
It makes sense. It's like, okay, this guy was smart enough to get down there, but how do you overlook that? If I can see that, how does he overlook that?
Well, that's a good question. And you have to dive deep into some of the details to understand it. And I think that came from that guy, Dave Spencer from Spencer Composites, because Spencer was a marine grade carbon fiber fabricator. And he's the one who built the Deep Flight Challenger for Steve Fawcett. And I think he talked Stockton into the fact that a thick carbon fiber hull under uniform compression can get away with a lot of manufacturing defects. Stockton said that in that meeting with David, where he fired David, and he could have only learned that from Dave Spencer. So I think that's wrong. I think that manufacturing defects have a big impact on a carbon fiber hull, even if it's thick and even if the compression is symmetrical.
What's interesting too is, with all with all of us as cyclists, as I mentioned earlier, we all ride carbon fiber wheels, carbon fiber frames, these things, and
Right.
obviously there's torsional effects that are very different than what is being experienced in the deep sea. But there's all sorts of, there's some wheels even that you can see the 45-degree plies
Right.
like laced into the wheels. This carbon lacing effect that provides it this additional strength. And it's just wild to think about the science of carbon fiber and how it's laid down and cured and all these things. Even in the second hole, when you were describing and you showed those photos of the end cuts, the idea that it was a little layer and then they would take it up the road, cure it, glue it to the next layer. It just is mind-boggling. It seems like such a bad choice to have proceeded in that way. And that was indicative by the testing they did at the University of Washington. And I was curious, maybe if you could pull up in your book, I think you have some photos of the failed 1/3 scale model.
Yeah.
Those scenes in the documentary were terrifying to me because they'd keep putting the pressure on in that lab, and then it made the big pop, and there was clearly frustration from the crew or from the engineers that were standing there.
Yeah.
And Stockton was really frustrated. It kind of was I know one of the documentaries focused a lot on his like behavioral traits.
Yeah.
And one of the things that was clear is that when something went wrong, he sort of shut down and was like very aggressive to everyone. And
Oh yeah.
Yeah.
He hated to be questioned. Let me see if I can share this screen.
Yeah.
Another thing that was in while you're doing that I heard Stockton say in that Netflix documentary was, I think it was maybe one of the later missions where that massive bang towards the surface occurred. His comment about like all submarines make a sound like that.
Yeah.
And I was kind of like,
Do
do
military
they
ones?
really
Yeah.
though? I don't.
Yeah.
I don't know.
Yeah. I know
Yeah.
exactly what you're saying. That was terrible too. And that's where he also kind of makes a nod to PH Nargeolet. And he says something to the effect of, PH will tell you, that they all make noises at some point. And it's a little disappointing that, PH signed on to that to give that whole business credibility.
Yeah, it seemed like he definitely took advantage of those Titanic experts, and that was part of the tragedy, right? Is there's these people that have had these incredible careers in deep sea exploration, spanning
Right.
20 or 30 years, and have been down to the Titanic and other submersibles, and they've made such a remarkable career of it, and then it ended in this bad choice.
Yeah.
It's really, really sad. But I see you've got the photos here, so I'll pull those up.
Yeah.
This is from your book, right?
Yes. This is in chapter 8. Are you seeing it now?
Yep. Yeah, it's up.
Yeah.
there.
So this is what I wanted to show you. So this is the 090 layup right here. So that's what the Titan had. And this is what Boeing, wanted them to do. Because this little red dot that I have here represents like an area of carbon fibers that got broken. So if this is broken, this circumferential loop now is no longer a loop of carbon fiber. It's got a discontinuity. So that means the neighboring fibers have to now take that load if there's pressure, or it can be transmitted to the longitudinal fibers in the area. But if you had 45-degree plies, either one way or both ways, now if you have a discontinuity in the circumferential loop, you've got more plies of carbon fiber to distribute the load. So that's kind of what that's all about.
Yeah, it's incredible. That miss of theirs, or their maybe their ignorance and wanting to just pursue something that. Do you think that there was a cost effective in their mind? Was it cheaper to not do the plies, or?
That is a great question. And here is what I think happens. I don't have a picture of it in my book because I didn't go into this because there was no testimony about it. But here's the deal. When you want to lay down carbon fiber in 45-degree plies around the shape of something that's like a big pill, you have to wrap it around the ends. So you have to use carbon fiber all the way around the whole thing. And then you're going to cut these off. You're going to throw them away on the ends. But that's what gives you the 45 degrees over the center of the hole. So it's a lot of money, a lot of work, a lot of time, and then a lot of wasted product to get those automated, those robotic carbon fiber machines to do the 45-degree ply.
Interesting. I kind of, when you were describing that, I was thinking about like, around the holidays and you buy like those little cylindrical things of ribbon,
right?
And they're sort of like in that, they're crossed in that way. It's sort of what I feel like it maybe should have looked like if it was done in the way that Boeing was recommending.
That's right.
But yeah, I guess I can see it from that side, if having to cut the ends off there and then discard that carbon based on the decisions that he was making financially for the company. I could see that being a reality of him just ignoring it or saying, we're not doing this. I mean, that was very clear with his cost averse mentality with the certification, and just saying, okay, well, yeah, this is, in his mind, it was optional, right? Like, oh, this is something that we're just not going to do. Whereas every other deep sea submersible makes that effort and spends the money. It's a non, it's an essential.
Talking about human life.
Yeah.
Right.
I don't care how expensive it was.
You have to do overkill at this point. So this is the mandrel at Spencer Composites. So you see, they would roll it on up and down the hull this way. And after every 2 plies, they would stop the rolling, and then they would hand lay the longitudinal plies. And then they would roll, 2 more plies and then hand lay longitudinal plies. But you see, the mandrel stops here. But if you wanted to do 45-degree plies automatically, like they did at Electro Impact, this mandrel would have to have a pill shape on both sides. And they would still have a hole in the top of the pill so that you can mount it to the spinner. But then later you would be cutting that whole dome off. And that's just, a waste of product.
And is that all, like those photos from Spencer Composites and assuming any other, the Collier one for V2, those are, I'm assuming, custom fabricated machines and dies and all sorts of things that were built to lay this up. Is that right?
That's exactly right. They built this stainless steel mandrel.
Wow.
And that's one of the things that Tony got hired when the mandrel was already built and designed. And when they built this mandrel, they built it about 8 or 10 inches longer than the size of the finished hull, because they would cut off this last 8 or 10 inches. And the reason is when this roller comes up and it goes this way, it has to go back this way and then come back and then go back. So the ends kind of have this weird overlap. You can't really use the ends because of that back and forth motion that happens there. So they plan to cut that off.
Interesting. Wow.
And that's when, when David Lockridge talks about seeing the cut end of the first carbon fiber hole, and he's freaking out because it's so porous. That's what he was seeing. He was seeing the end you're going to throw away anyway. And that's not really representative of what the center of the hole looks like. So he was a little bit freaking out needlessly.
Wow.
Now, this is what I wanted to show you guys too about your carbon fiber bikes and what's the difference between titanium or metal bikes or carbon fiber holes or carbon fiber bikes. So materials that are carbon fiber or wood are called anisotropic. And that means they don't give like metals. Metals can give, they can bend a long way, but then they can come back to neutral. And when you push them too hard, they still become plastic and they deform, but they don't break. But woods and carbon fiber don't work like that. They're called anisotropic, not isotropic. So what Roy Thomas from ABS testified was, with carbon fiber, you can push it, you can push it, you can push it, but all of a sudden when it goes all the way. Now, when I've been reading on these different forums about the Titan, there are a lot of cyclists like you guys out there that talk about their carbon fiber frames. And a lot of guys talk about this. They say when they go all the way. It just breaks all the way. Have you guys ever had a carbon fiber piece just break?
It's kind of a sensitive topic right now.
Literally last night. Yeah, literally last night at the final race of our weekly summer race series we do at a place called Grattan Raceway. There was a tumble that took place in the field, and one of our teammates who has a brand new, beautiful bike, literally brand new. He just got it 2 months ago, if that. And the seat stay. So the two sort of pillars that go down from the back of the seat post down to where the derailleur are, one of the seat stays was just like cracked in half. It just went, and then I had a similar situation with a mountain bike earlier this year, where riding in very typical conditions for the type of bike that I have, hit a rock with the tire. I was not seated, and yet the seat stay still broke, and when it broke, it fully gave. So it's very that picture of the wood, I think, really paints it clearly, which everyone has the experience of trying to break a piece of wood, and it looks just like that, right? When you're trying to break firewood or whatever it is, it finally gives and splinters, just as you see there.
And that's the problem with carbon fiber. And so the other thing I wanted to show you guys in this chapter on the ill-advised grind spots, if I can find it. So we were talking about doing these layers, right? So they're putting down these layers. And the reason they were doing 1 inch at a time is they were trying to prevent wrinkles in the carbon fiber. Because what happens when you lay down this carbon fiber and you cure it, it shrinks. And it doesn't shrink symmetrically. So some of the fibers are longer than they need to be as it shrinks down. So they bulge outward. And that's a problem, because a bulging carbon fiber means it doesn't have the strength it's supposed to have. So when they were doing these holes, what they were finding is that they were getting these little bumps on the top of the carbon fiber. I got to try to find my pictures. And so what their answer was, which was just crazy, was to grind down the bumps. So they so picture what's happening here. You see all these bumps that are on the surface. The last surface they don't have to grind down. So here's the first one. We looked at that before. Let's say you have these bumps here and you grind them down, right? So this is the first layer of the 5. You grind down the bumps because you want it to be smooth so you can put on your adhesive film. So then you put on your next layer, and then you have these grind spots below, which you don't see anymore because you've covered them. But now you grind the second layer. So now some of these grind spots could be right over each other, right?
Right.
Then you put on the third layer and you grind those. And then you put on the fourth layer, and you don't have to grind the fifth layer because that's the outer layer. So you see what happens is you get all of these grind spots that could be in the same location, And since you only have a 0-90 layup, you don't know how those loads are being distributed. When the NTSB looked at the cutoff ends of this hole, they found they found a lot of grind spots, but they found this amount of plies being ground down. So plies removed by grinding varied from 1 ply to 12 plies. And you have to think about this. A 1-inch layer of carbon fiber was 133 plies. So if you ground down through 12 plies, you've almost ground down 10% of that area. So what we were talking about before was buckling. When you have all of these areas that you've done all this grinding on, let me see if I can find the picture, between the carbon fibers that are breaking, between the carbon fibers that you've ground down. Here's an example of grinding it down. You see, they would grind down the carbon fiber so they could put the glue layer on before they put the next layer of carbon fiber. Well, when all these grind spots overlap each other, and then when you might have carbon fiber popping, what you can have is these areas of the hull where all of these things are overlapping. That's what these little red blotches mean. So this may be an area where you have grind spots and you have weak fibers, right? And this is where you get out of roundness. Because if you have an area of a hull that has multiple problems going on at the same time, including the porosity in the carbon fiber layer and perhaps not full adhesion of the film glue layer, this little area can push in more than the surrounding areas. And then eventually, it's going to go. A lot of people use the analogy of you can stand on a Coke can as long as you're perfectly vertical on the Coke can and you don't tilt one way or the other. But if somebody pushes on the edge of that Coke can with a screwdriver and puts a little dent in it, it's going to go all the way. And that's what out of roundness is. And that's what may have happened to this hull.
Wow. Yeah, the science of the carbon fiber, and just where the industry of carbon fiber is with all these clear indicators that 45-degree plies would have been like, it makes me wonder if they had done the 45-degree plies, if this would have never happened, and maybe they'd still be diving, right? Like,
yeah, if they listened to Boeing, they would have been in a lot better shape. It would have cost them a lot more money. It would have been in better shape. Because here's the other thing, and then I'll stop sharing this and we can talk. So this is the NTSB cutting through layers of the carbon fiber. So this green here is that glue that's in between each of the 5 layers. That's the glue film layer. And look at all the voids that were in that. It wasn't even 100% adhesion. And so the point of that is, if this is going to behave as a 5-inch thick hull, these 5 layers have to be glued together and must act as a single unit. There cannot be any motion or any flexion in any of these layers. Otherwise, it's not behaving as a 5-inch thick hull. And the NTSB actually found areas in the adhesive that was grinding itself away to dust. And this may be one of the reasons, this is hypothetical, this is my theory now, this may be one of the reasons why the second hull was quiet, because the motion may have been happening in between the layers to relieve the stress on the carbon fibers, right? Because there may have been some sponginess to the hull based on the fact that it could move at the glue interface. This way it didn't have to strain the carbon fibers, but I don't know.
wow.
But anyway, I'm going to stop sharing and we can
that makes a lot of sense to me.
Yeah, it definitely does. We were talking too about how mind-boggling it was that even when they had the big crack in the first hole, right? And they talked about how they ground that down, and it was such a deep crack that I can't recall exactly how deep they had to grind until they couldn't see a crack any longer.
Right.
But it clearly was deep into the hole, and that when they built the second hole, they just kept going with the sequence of dive numbers as if it was the same hole.
I know.
Yeah.
Like 50, 51, 50. And that just doesn't make any sense. Like it's a completely new submersible in some ways, right? Different strategy, different manufacturer.
Yep.
And yet they said, we're going to continue on. And I think that's another way they pulled the wool over people's eyes by saying we've had, umpteen successful dives. Like you said, even the ones
Right.
that were 10 feet in the water were counted as successful dives. That's just incredible that they did that, and really a shame.
Oh, it's funny. The only time I've seen Stockton get caught off guard in an interview was during the Discovery documentary when Josh Gates asked him that. They were getting out of the sub, and Josh was saying, well, like, how many dives have you done, Stockton? This is right before they were going to start the 2021 dive season. And Stockton said, well, we've done, 56 dives or something. And then Josh was trying to press him. He was trying to say, but it kind of doesn't add up. Like, in this hole, how many dives have you done? And Stockton was like, blah, 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 blah. He was caught completely off guard because that hole had done no dives to any deep depth. But yet they're calling it, dive 58 or whatever. That was really funny to see him get caught off guard by Josh in that one interview.
Yeah, it makes total sense. It's very logical to want to know that.
Of course.
And yeah, it's just such a shame. It's just yet another instance where his salesmanship and his ability to sort of charm people, and people trusted him as a result, just not thinking through things clearly and getting caught in a bad situation. And I wondered too, like with the first hole, with the cracking that was experienced in that, the popping sounds, it's a very eerie scene in that documentary where he does the solo dive down to 3939 meters.
Right. And
you would just wonder, like, that was sort of a miracle that he made that one work. It's wild to me that obviously there was the whole transition. They moved into the second hole and that sort of reset the stage for them, but that it didn't happen sooner, right? Like that's something that I think rings very clearly in these documentaries, and in your book, is like there's so many signals of failure occurring in so many different facets of this project, that you wonder how it didn't fail sooner.
It's incredibly complex. And I'll just 2 points about that. First of all, he did that solo dive and heard all of that popping, and even he was scared. And he would attribute that, I guess, to seasoning the hull, but it was clearly problematic. But yet he had the nerve to take 3 other people on that sub to the same depth, almost. I think they got down to, I don't know, 3,700 meters or something. That was the dive that Carl Stanley was on. And Carl Stanley, testified at the Coast Guard hearings that, Ocean Gate almost killed him. And they did. I mean, that hole could have imploded on the dive with Carl Stanley, the second deep dive in the Bahamas, for sure. The other thing about the dive numbers. So we talk about dive numbers now because after the hearings, the Coast Guard released the Titan or the Ocean Gate dive logs. So we associate these dives with numbers. But you got to remember, in 2021, 22, and 23, those mission specialists didn't know what number dive they were on. They referred to their dives as their mission. So each expedition was the year. So like it would be the 2022 expedition. And that expedition might have 5 or 6 attempts at diving to the Titanic, and those were called missions. So you can talk to a mission specialist from 2022, and he'll say he was on mission 3, but he won't know he was on dive 80. That wasn't the terminology. We use it now only because we've seen the dive logs, but they didn't know that. So they had almost no idea what dive they were on. Not that it made any difference anyway, because like you said, the first 49 dives had nothing to do with the second hull. But they would have been shocked to know like they're on dive 60 something and they're only on the 17th dive of that particular V2 hull. I mean,
Yeah.
they had no idea.
Those are all questions I would want
It
answered before.
Yeah.
Yeah.
Not that I would ever get in one, but if I was considering it, I would
Right.
need to know those things.
Yeah, like how
Exactly.
many hundreds of times has this been successful? That's what, like
right.
we've talked about that with the Dear Moon mission, right? Like these content creators and these artists. Obviously, that mission has now been canceled, but the Starship's still very much in development. It did have a
Right.
successful launch, 2 days ago, but
Yep.
on Flight 10. But we put ourselves in those shoes of like, what would it take to truly be like, you know, we have this podcast, we all signed up for Dear Moon sort of jokingly, but who knows? I mean, what if one of us was selected in some random miracle? What would it have taken? And we all talked about like, oh, we would have to see that thing like to perfection 100 times or whatever it may
Right.
be. And
Right.
you put yourself into these shoes of these mission specialists, as you said they were called, and being revealed that information that, oh yeah, you're actually on dive 3.
Again, I go back
Yeah.
to like, you know, you were talking about the Bahamas. They got to 3,800 meters. You're not seeing anything at that point. At least if I'm going to outer space, I get to see Earth from space before I perish. If that's my destiny. But
Right.
in those, it's no different than going in a sensory deprivation tank because
Yeah,
it's just
exactly.
darkness and you're in this little cylinder. Like, okay, you can say you were, 15,000 feet below the ocean surface, but you didn't experience anything. I just don't understand the allure. For me, it just is a non-negotiable. I'm not doing it.
Yeah.
I don't get it either. I mean, I'm not a biologist and I'm not an oceanographer, and maybe there is stuff to be learned at the seafloor at 6,000 meters. I don't know what. There is life down there, and I guess it's interesting to take video of it, but I don't know how that helps society or mankind. I mean, you can make the same argument about going to space. I don't know how all of this is going to help us. I mean, I don't really think we're going to populate Mars. So I don't know. I mean, it's just people have a desire to explore, and that's just what it is.
Yeah. I also question, not only, I mean, we're talking a lot about like the hull and things like that, but like the controller that was used to maneuver this thing, like that. I mean, there was a video of Stockton like just tossing it on the ground. I'm sorry, but like I have a PlayStation and the controllers don't always work. I mean, there's like that's another part of it too. Like I would look at that as a potential mission specialist and go, is this like we're going pretty far down, and if this thing breaks, I mean, I don't, the controller breaks, something like that, like doesn't work, that would be terrifying too. Just I don't know.
I agree.
Yeah.
So the point of that was Stockton wanted this thing to feel like it's user friendly, and that you can train somebody to drive it around very quickly. He didn't want it to be technical, like when you see the inside of like the Alvin submersible. I mean, that his concept was simplicity. Now, he said they kept a couple of spares on board, and I remember one of the early Applied Physics Lab interviews, that Dave Dyer guy said that it could be hardwired into the system if they ever had a problem kind of with the Bluetooth. I mean, I don't know how true that is, but you're right. I mean, it seems scary. But the goal was to make it easy to drive it around. And, the crazy thing was in that dive it was dive 81 with Renata Rojas. After dive 80, they had to change out a thruster, and they mounted the thing backwards. So when Scott Griffith got down there to the bottom and he was trying to go forward, since one of the horizontal thrusters was mounted the opposite way, he was just spinning. Because one was going one way and one was going the other way. So he had to figure that out on the bottom, that he had to do one joystick the opposite way to get to go forward. I mean, that's a huge mistake. I mean, you don't dive off the sub after changing a thruster to not know that you have the thing mounted the correct way.
Yeah, it's incredible.
That's where I just have questions about like the regulations and like, they're just doing everything kind of on the black market, if you will.
Yeah.
And they're, nothing is up to any kind of code or spec. And
yeah,
you're asking for problems.
You are. They had problems on every dive. It was a nightmare.
So I'm assuming they have more information like this, and I've seen some things put out there online about the final dive and transmissions from Titan up to the surface, that kind of thing. But did they know they were in trouble leading up to the implosion?
I don't think so.
You don't think so? Okay.
No, I think things were smooth all the way down to the point where it imploded.
Wow.
That's why when Stockton or when the sub, texted up, dropped 2 weights, that would have been a normal call at that point.
To start slowing down.
Getting close to the bottom.
Yeah.
It's just a wild tragedy. And I want to give you a chance too to promote your book sort of as we wind episode 87 down.
Okay.
Because I think it's really important. I mean, the work that you've done, again, like this is all data that's out there, but you've deciphered it and you've put it into a concise, relatively concise narrative in a way, right? Similar to what the documentaries are trying to do, but in a much more granular way that does fill those gaps. And so I'm going to throw it up on the screen again here as we wind down, but titandives.com is the site. And the book is available in a hard copy, just as we have it here, which is incredible. I think it's a fantastic thing to have, like you said, just to be able to hold. But it's also available as an ebook. Is that right?
Correct. And a PDF. Yes. So one of the things I'll say about that is, the testimony, the Coast Guard testimony, I watched all of it, actually downloaded the transcripts and made my own question answer manually of all the transcripts from YouTube. That was 70 hours of talking. Wow. And it was very slow moving. And the other thing about it is the Coast Guard would talk about some particular story. I mean, let's say it's the hull. And so like on day one, they might be asking one witness questions about the hull. And on day 4, they might be asking another witness about the same questions about the hull. And then they might ask the same question a different way that same day to the same witness. So the point of the book was to take all of these little snippets of information that are about a particular subject, spread over 8 or 9 days, and then coalesce it together into the story. And that's what I think the benefit is. If you are interested in this, what my book helps you do is just understand it. It helps you understand what has been wrong about what's been on social media. It helps you understand the final report, because the final report has a lot of information that's not needed to understand the tragedy, because they had to spend a lot of time on nautical stuff, and there's a lot of words and a lot of repetition even in the final report. So my book hones all of that down. And I'll say one other thing. The documentaries were excellent. I mean, I thought they were very well produced. They were very professional, as you would expect from Discovery and Netflix. But the script was written to disparage Stockton, right? So the whole narrative was about disparaging Stockton. That's how it started, and that's, how it ended. And in fact, the Discovery film was even worse than that, because they ended with hanging a carrot out there like, will there be criminal charges? That's kind of what they wanted. My book is not like that. My book is neutral towards Stockton. Now, when he made bad decisions, I mean, I discuss it in the book, but I discuss it in a neutral manner. And a lot of the people who are involved with the Titan and have read my book, appreciate that. And the reviews on Amazon have been excellent. It's just been really gratifying to see people appreciate the information in the book, especially people who were involved with Ocean Gate and Titan. So, I'm gratified. I feel like I did a good job, and I don't know, I just did it because I just felt like I needed to do it. So I'm happy to talk about it. I'm glad you guys had me on. I appreciate it. And hopefully some other people will get the book and learn about it.
Yeah, absolutely. It's incredibly impressive, and you did do a great job. And it, just as you did with your 2024 Eclipse Guide book, I mean,
Mhm.
and it's sort of the same idea, right? You're taking complex information that you may find spattered throughout the internet. You may find it through the lens of a forum or something, and you're taking it and putting it into something that's sequential in nature, or in the case of the Eclipse book, of course,
Right.
getting you prepped from the journey for the whole journey, and this book sort of takes you through the journey of this Titan submersible story in a way that I think is really interesting. And so yeah, I feel like it fills the gap nicely, and yeah, fantastic work, very very impressive, and thank you
Well,
so much as always for
no, I
being
appreciate
here.
it. This is
Thank you
going
for
to be
sharing
talked
it with
about.
us.
This will be talked about for a long time, just like the Titanic was, and I think this book will be a reference book to what was in the hearings, because 5 years from now, people are not going to rewatch the hearings,
Right.
but you can pull out this book and remind yourself about what happened and what the controversies were.
Yeah, absolutely. Well, kudos to you. Thank you so much, Gordon, for being here on episode 87. We'll go ahead and wind this episode down. For those of us, again, yeah, go to titandives.com, explore the page, purchase the book if you're interested, and then leave a review for Gordon and this incredible amount of work that was put into this. And then for us, if you like this episode, if you like what we're doing with the video, we're gonna try to take it to the next level in this coming year with more videos. So follow us on Instagram at Eclipse on Tap, on X, at Facebook, and all the places that you'd find social media pages where we're there. And then, of course, Apple Podcasts and Spotify are the primary podcast sites. And then this will be on YouTube as well. So kind of a multifaceted approach. And we did this with Gordon back in February when we reviewed the Eclipse from 2024. And so pleased to be able to do it again with you here today. So
Well,
cheers
thank
to you.
guys. Yeah, I appreciate
Yeah.
it. Thank you.
Cheers.
Cheers. Thank you very
Cheers.
much.
Cheers.
Cheers.